Hi guys, back here with an update video. Just going to show you off the efficiency of the system. And we're at a point where I'm not sure if I should keep focusing on efficiency or if I should just scale it up the way it is now to run really big, heavy loads. So what we have going on is we have two resonant receiver coils connected in parallel, powering up an LED light, pretty bright, and our input power is 0.03 milliamps. So we have the transmitter being run off a 9-volt DC battery. Coming in a series connection off the negative input line is a 150 ohm 5 watt carbon film resistor. We then have a 10K 5 watt potentiometer carbon film that passes in series with our multimeter in current mode so we can read the current, and that just feeds into our transmitter. The transmitter is in the center here, and it's heavily earth grounded, which greatly increases the wireless power effects, and you will not get the phenomenal wireless power effects unless you heavy earth ground it, which is this green wire here that goes all the way to my heater, to my heavy earth connection on the heater of my farmhouse. And yeah, basically just thought I'd give an update video. I've been focusing on really trying to refine the efficiency. I'm at a point now where I'm not sure if I should scale it up or keep pushing for efficiency. The interesting thing with this system is, based on all the math calculations, if I direct this energy into recharging a capacitor, this energy over time is more energy than the input energy. So we're able to brightly light this LED light from our receiver coils, and you see if I touch the transmitter in a certain way, the light will get dim. It actually went out. Get it back up in operation again. Okay, so if you want to enhance the wireless power effects too, you can make a bifilar transformer, which is just two wires side by side, and you wind them. You take two wires side by side, wind it on a ferrite rod, and you earth ground just one leg of that stranded wire, leave the other leg open. The other leg could go to a full bridge rectifier and connect to a resonant receiver coil and give you even more power. So that's what we're doing. We're enhancing that effect. We have it earth grounded into our DC power supply that's off, going through a bifilar coil. There's not actually a physical connection here. As you see, we earth grounded one of the bifilar legs. The other one remains open, and it enhances, the earth ground is enhancing our power effects while we still have wireless power. And for these little receiver lights, point contact germanium diodes seem to be the best. It seems as if you use point contact germanium diodes, you can get a form of loadless wireless power transfer, meaning the power you transfer doesn't place a load upon your transmitter. And the reason for that, our research group was heavily investigating, and what we discovered is the system is inductively coupling with the earth when you heavily earth ground it, because the earth is a good inductor but poor conductor. So this system is inducting with the earth ground, creating the apparent gain in power functions. That's where the gain in power apparently comes from. Again, we're at a crossroads. Not sure if we keep focusing on efficiency with the system or if we should scale it up now. I believe we switched to a BC548C transistor. And if I can tune this, and for those who don't think that the transmitter is being run off this, if I turn this up, we become very inefficient. So as you see, we are now consuming 7 milliamps. because I detuned the potentiometer. I'm actually going to put the light on that so you can see it better. We're using 7 milliamps now. LED light didn't really get much brighter. I'm going to try and get this LED light in frame for you when I tone down the power levels. So now I'm choking back the power with the potentiometer. So I'm showing you that this wireless power system, the efficiency in it, comes from the switching action within the transmitter. It's not so much the raw amount of wireless power you're transmitting, it's the switching action that seems to be the catalyst for energy manifestation in wireless receiver coils. So as you see, we toned it back down to 0.3 milliamps power consumption. Our LED is nearly the same intensity, not really much of a difference. Again, the system has to be heavily earth grounded for this to occur. Now, if you were to charge a DC capacitor with that and do the calculation, the charged DC capacitor will output more power over time than your input drain. But again, I'm not really trying to achieve that. I mean, I could achieve that, but what I'm really aiming for is to create a system that's fully self-sustaining, meaning I get a slightly more efficient transistor, maybe get the power consumption down to 0.2 milliamps or even 0.1. The system will have a bank of resonant receiver coils. Those resonant receiver coils will then replace the battery. That's my goal. Because if I can completely replace the driving battery, once this thing is started off of resonant receiver coils, that would be the goal. That would be a true independent energy system, where once it's earth grounded and once you start it, it's inductively coupled with the earth and the earth sets it off running. So that would be the theory behind how it works. And our nearly self-switching transistor is what would run it. And again, our study and observations of the system seem to show that the efficiency comes from how efficiently you can create that switching action within your transmitter. The more efficient you can do that switching that disturbs the high Q rest state of your coils, the better off you will be. And you can achieve a form of loadless, wireless power transfer with resonant receiver coils. That seems to be the key. You need point contact germanium diodes to manifest the wireless power that is loadless. The diodes have to be point contact. They can't be Schottky. You have to have a point contact germanium diode for that. I think I'm using 1N34A. It'll be in the video description. And these receiver coils, this design seems to work the best. I tried this design, didn't work out that well. So this design is 4 quarter-sized receiver coils. Basically, what's going on is each receiver coil is like a super receiver coil. It's 4 quarter-sized receiver coils, all in with their outputs in parallel to one bridge rectifier, giving you the power that can do that to that LED. So we took a ferrite rod that's twice the length of the transmitter. We put 4 quarter-sized receiver coils on here. For this system, that seems to be the most efficient. 4 quarter-sized receiver coils in parallel, just connected to the AC side of our bridge rectifier, composed of 1N34A germanium diodes. The other receiver coil, it has its connections in parallel. We technically have 3 receiver coils here, all connected in parallel, getting that LED light pretty bright. But the interesting thing that I encountered, the interesting problem, is this power output. This power output at this spot is higher than the input. But the strange thing is, when I feed back that power into the battery, that 9-volt battery is only designed to recharge from the charger, which stinks. And if I also run it off a supercapacitor, like these guys, a 10-volt supercapacitor, the strange thing is, even though this power output here is higher than our input, because we're receiving excess wireless power from that loadless power transfer, the weird thing is it can't self-sustain itself yet from this output. The system will just pulse. Sometimes it'll be stable, sometimes it won't, but it will pulse a very faint power output. Like this output here would pulse, and it would read itself as not consuming any power, and the wireless power would just pulse. So it's either very close to the point of self-sustainment, or it can't quite do it yet. I'm not sure. I'm not sure why that problem is there, even though it seems we have excess wireless power, given the fact this LED light shouldn't even be lit at all wirelessly from an input power of 0.03 milliamps at 9 volt DC. So we're running that LED light wirelessly from 0.03 milliamps at 9 volt DC. And if you doubt that, I'll detune it again. I'll try and get this in good view for you. I'm going to try and keep this video a little bit shorter because I know a lot of people don't like long videos. And connect this. There we go. Might not bend. No, we got it. Alright, so I will crank the potentiometer up, detuning it. And this thing is very sensitive. Just touching it in certain spots can shut it off. So the potentiometer is cranked up to full power. We're consuming 7.5 milliamps now. And like I said, that's not so much where the efficiency comes from. Notice how I cut back the potentiometer power. Our light doesn't really dim that much. So the potentiometer is the key to achieving the higher output power than the input wirelessly. Oops, there we go, come on. So there we go, we are on consuming 0.3 milliamps. Demonstrated that. Obviously there's nothing under the desk, nothing under any of the desks. So this thing is highly sensitive. It'll shut up. If I turn it up a little bit, it'll kick on. Okay, so we're kicked on again. Yeah, so that was what I wanted to say, what I wanted to show. That's about it. If you want to buy any products, feel free to read the link in the description. All sales are done through our Patreon page. And you email us to mtechindustriesshop2022@gmail.com if you want to buy or order anything. You have to watch out though too. If you're in another country and you order, it's going to be expensive to ship to you. And sometimes customs rips open the box and can completely rip apart fully assembled products. So that's something you have to be warned about, is if you're in another country, you're going to have to pay possibly an expensive shipping fee for anything bigger than a basic efficient transmitter setup. And sometimes customs rips open the boxes, and sometimes they even disassemble things, which is very irritating. And yeah, basically, if you're in the US or anywhere in North America, there's not really any issue with shipping. It's overseas where the shipping can become an issue. So that's that. I showed off the efficiency of the system. To sum it up, we have a heavily earth-grounded joule thief transmitter circuit. Our goal is to push it to become the utmost efficient we can make it by using Moray valve energy concepts in it. Our goal is to make this thing fully self-sustaining by getting even more efficient transistors as they come out. I'm at a crossroads point where I'm like, do I keep pushing for efficiency now? Or do I just take what I have and scale it up to recharge big batteries, run light bulbs, make improved ringer generator boards? Because what I'm trying to do on these small power levels is get a really strong idea and understanding of how the system works. The true core principles of the wireless power transfer mechanics. And like I said, what we discovered is the system is inductively coupled into the earth with that heavy earth connection, and it manifests wireless power when you have your germanium diodes. The thing is highly sensitive with germanium diodes. I actually don't think that's quite the right one because I experimented with different setups. The germanium diode gets really bright when you're even near the multimeter. I know I have one around somewhere. This could be it. Really should have put those in a separate bin. But anyway, as you can see, the germanium diode is much more sensitive. So yeah, anyway, back to the system, summing it up. You want to know how it's constructed? That's detailed in my YouTube page community post. You just go to my channel, go to the community post, and you'll see a full detail on how it's constructed. It's a 200 millimeter by 10 millimeter nickel zinc ferrite rod. The L1 coil was switched from 28 gauge to 26 to get slightly more efficiency. Doesn't really matter. Your L1 can be 26 or 28 gauge. Your L2, the thick outer coil, is 16 gauge. Very heavy, high quality 16 gauge. And as long as those two coils are wound opposite to each other, you're in business. You heavily earth ground the thinner coil, your L1, and that's really all there is to it. I'll give you a good look at the transmitter in the video. You don't even need this video to build the transmitter. The full schematic is in my YouTube channel community post. And again, for those looking to purchase a transmitter unit, an efficient one, a transmitter unit kit, the link will be in the description. Once you order, you just email us your address. Again, if you're outside the US, be aware you will have to pay for a higher shipping price, and anything more complicated you order than the transmitter system, Customs does like to rip it open, and sometimes they even damage it. They'll rip it open, either inspect it, they even take it apart sometimes. Very annoying, but it's just what happens, I guess. So it's recommended for people who are in the US to buy. If you're outside the US, it's recommended to build it yourself with the schematics I provide. Everything's for free. We're an open source research company. We don't hide anything. But yeah, if you're outside the US, it's recommended to build it yourself from the schematics, or if you want to risk ordering it with Customs tearing it apart, go for it. Anyone who's buying more complicated things, definitely recommended you be in North America or the United States. And yeah, again, to sum it up, it's not any magic running it. We're trying to build a self-sustaining wireless power system as efficient as possible, inductively coupled with the earth to enhance the power effects using a Tesla style of power transfer. We are not using the earth as a conductor. We are using the earth as an inductor. Big difference. Very important. That's why we can get it to such efficiencies with the ability to wirelessly light this LED light. And that's about all I wanted to say. And thank you everybody for the support. Gave an update video. Again, the loadless wireless power transfer occurs in resonant receiver coils. When you use germanium diodes, have to use point contact germanium diodes. I'm using 1N414A. There seems to be apparent, and I say this loosely, apparent over unity. If you were to direct this output to charge a capacitor, you have more power output over time than your input. That's one method of going about it. The other method I'm trying to achieve is full self-sustainment. So a better efficient switching transistor combined with maybe slightly higher yield receiver coils can then have their outputs connected to the battery, and then I disconnect the battery and the resonant receiver coils run the system in place of the battery, and it's fully self-sustaining. And what's running it is the Earth's natural electrical system inductively. That's where the gain in power function would come from, is from the Earth's natural electrical system inductively. So that's what I'm pushing for. I'm probably going to keep focusing on efficiency before scaling it up, because I can scale this thing up at any time. I would just get a slightly bigger battery. I would upgrade the transistor size, increase the amount of current flowing through, and essentially wirelessly run whatever I want once I have the efficiency nailed down. And it can basically run whatever you want. Charge 12 volt DC batteries, run an AC inverter, 120, 240 volt. And the key I'm going for is full self-sustainment of the transmitter system with an additional resonant receiver coil, giving you trickle amounts of true, pure excess power. So that's that. Hopefully I summed it up. I gave you guys an update video, explain the concepts. Anyone looking to support the Patreon, feel free to, because we're trying to grow. Anyone wants to order anything, if you're in the United States, you're heavily encouraged to. Shipping is very cheap through the U.S. Postal Service, and customs doesn't tear it apart. If you're overseas, you're going to have to pay about $40 to $50 in shipping, sometimes even $80, depending on what you get. And you have a risk of customs tearing apart what you order. And yeah, thank you everybody. Feel free to support the Patreon. Feel free to check out our community post where we have the schematic. That's that. I said the video wasn't going to be long, but it's important to get all this information out there, show you everything. So yeah, thank you everybody. I explained the concepts, and that's an update video.